Welcome back. This is 311 part 2. So question 3-4, reflections. So the shape created by Hunter in problem 3-3 was a result of reflecting the figure over a pole. A reflection across a line is shown in the diagram at right. The reflected figure is called the line of the original figure. The image of the original figure, sorry. So what do you think the image is called a reflection? And how is the image different from the original? So again, the dotted line is what we call the reflection line. And if you guys can see, there's pretty much a reflection line on all these problems, right? So if we were to reflect things across that line, what do you think would happen, right? So again, if I rotate this 180 degrees on the other side, right, I get pretty much this shape. Two down and this one. All right, so that looks pretty close. Right, now question 2, right? The line of reflection is right here, so I'm going to do the same thing. So this point stays there, right? And then this point's over here is going to be down there. And then this point down here is going to be 2 away from the line of reflection, right? And this one's also going to be 2 away from the line of reflection. So now I pretty much connect my dots and I get my new reflected image. All right, so let's look at problem 3 again. The line of reflection is here. So this point, it's going to get reflected straight across, right there. And then this point also, so that was like 2 right there. Okay, so these two go together, right? I just connect those 2 points. And then this one goes 3. So about right there. So that's our next line. That one's been reflected. And then I want to create this one. So again, should be right there as well. So that's the next line. And then from there, we're going to go down. So we want to reflect this line. So I got to find the next point, which would be right here, am I guessing? Oops. Yeah, right there. So this 2 is right there. And then this point over here, we want to reflect it. It's going to be down here. So that's pretty much our final shape. All right, so same thing for question 4. So if we were to pretty much reflect this, right, across that line. So again, this point stays there and then this point stays there, right? And then this goes over here and then this chunk gets reflected across the line, right? So first let's reflect this part of the rectangle. So this point would be reflected on this side. All right, so we're going to connect those 2. And then from there, this point is this one over here. So we connect those 2. And then we just connect that part. All right, so we got that part reflected. Now let's get the top part reflected over here, which is this chunk right there. We'll do it in blue. So again, it's just a rectangle, so I can just complete my rectangle, right? So it goes 3 and then to the right. All right, and that's our reflected image. And then the next one, it looks like a kind of like a 7, right? If you were to think about it. So number 5. So again, this line right here is 4. So I'm going to go 4 this way, right? Because my line of reflection is right here. And then from there 2 down, right? And then 3 to the opposite side. And then from there straight down. And then we pretty much get the letter T. And then finally on 6, if you guys can see, did anything pretty much, if I were to reflect this letter, the letter M, right? the letter M across this line, right? Then this side will land on this side, and it would be pretty much just the same thing, right? So nothing would change there. Okay, so what do you think is, so again, the image is called a reflection, right? Because again, it looks, everything gets flipped over, right? Everything gets flipped over. So let's say everything is reversed, is flipped, and, right, how is the image different from the original? Everything's flipped, and then it's called a reflection because they're all the same distance to the line of reflection, right? So all points are the same distance to the line of reflection. All righty. Okay. And then it says question 3.5. Sometimes a motion appears to be a reflection when it's really not. So how can you tell if a motion is a reflection? Consider each pair of objects below. Which diagrams represent reflections across the given lines of reflection? And then try to answer in complete sentences, right? So if we were to look at the first one right here, if I were to see problem 1, right, this is a line of reflection. So I want to make sure that all these, like this points is the same distance across from right there, right? So if these two are the same distance right there, then it should be considered pretty much a reflection. And I think this one is a reflection, right? Because if you guys notice, all the points are the same, pretty much the same way. So this one is a reflection. This is a reflection. All right. If we look at 2, so this is the original image, and then this is the reflected image, right? So here, if you guys notice, this part ends up down here, right? It didn't go straight across. It looks like it pretty much went this way, like it rotated, right? So I would say this is more of a rotation than a reflection, right? Because if you were to rotate things here, this part would also end up right here. So again, it looks more like a rotation because it's not straight across. So this is a rotation. All right. And then problem 3. So pretty much you have the same image here, right? Nothing changed. She just went straight down. So since nothing changed, right, it's not a reflection. If it would have been a reflection, then this would have been flipped over, right? It would have looked something like that. But in this case, it's not. So we would say, move out of the way. We would say this is more of a translation. That's the mathematical term for it. So this is a translation. And then part 4, so the hearts, what do you guys think? Is that a reflection, a rotation, a translation, or maybe even a rotation? What do you think? So in this case, I would say this is also a reflection. All right, this is a reflection. Again, same thing, right? You can see that the shape of the heart is pretty much like all the points are the same distance away to the line of reflection. So that makes sense, right? Like when you look at yourself in the mirror, if it's a regular mirror, then you see that pretty much all the objects appear to be the same distance away, right? Like if there's something behind you, it's going to be the same. Like if you turn around, you're going to see almost the same distance, right? All right. And then the last question right there is going to be an open-ended question. Is it possible to reflect any shape? Is it possible to have a shape that, when reflected, does not change? And then how does reflection work? Sketch and label diagrams to illustrate your reflections, right? So again, is it possible to reflect any shape? Think about it. Can you put a mirror in front of anything and it will give you another image or not? What about when you reflect a shape, will it change? Like it won't change if you look, will it look the same? Pretty much, right? For example, like the letter M over here. All right. How does reflection work? And again, and I mentioned this earlier, right? So think about it. Most, like all points are always the same the same distance to the line, right? And then create a couple of illustrations and diagrams to pretty much finish the lesson.